So the next challenge I want to briefly touch on is IT versus OT divide, which is very real in many industrial environments, right? Traditionally, IT and OT networks are intentionally separated. OT networks are designed to be highly deterministic, tightly controlled, and protected from the external influence. And in many cases, there's a strict air gap between the IT and OT. And communication is allowed only in one direction for a specific use case of monitoring or predictive maintenance. The underlying principle is simple, right? OT systems should not be exposed to any inbound traffic that could impact safety, availability, or control loops, and so forth. And now when enterprises start thinking about using private 5G, this creates a dilemma. If you allow the traditional model, you would end up deploying two separate private 5G networks, one for the IT devices, one for the OT devices, and that increases the cost, it increases complexity, and it kind of undermines many of the benefits I talked about so far. And for example, there's also a growing demand for selective interaction between the IT and OT. A specific set of devices, maybe tablets or handheld devices used by the field operators, may need to have access to OT data for alarms or status information or work orders. So while still being governed by the IT security principles, these requirements aren't fully bi-directional access, right? It's controlled and policy-driven interactions. So the real challenge becomes, how do you use a single private 5G infrastructure while still respecting the IT and OT separation? This is not just a network problem, it's a policy and segmentation problem, and you need isolation between these different traffic. And that's how we developed our solution for these kind of environments. And this is the way we address the IT and OT challenges by using Celona airlock solution. The core idea is simply a single private 5G infrastructure with truly air gap behavior between the IT and OT environments. So instead of deploying separate networks, we use microslicing to create hard isolation between traffic domains, while still sharing the same radios, spectrum, and physical infrastructure. IT traffic and latest density OT traffic can be completely isolated at the physical layer while still operating under the same 5G LAN. On the back end, this separation continues at the edge and the core as well. Our edge platform supports explicit traffic separation by interface. For example, one physical port for IT traffic and a completely separate port for OT traffic. Each site can connect its own switching, firewall, and policy stack to separate ports on our Celona edge. From security perspective, this preserves the OT security model, and OT remains isolated by default, and inbound access is blocked unless explicitly allowed for the IT devices. The important point is that this is not flattening the IT and OT into one single trust domain. It's enforcing the separation while eliminating the inefficiencies of duplicate physical infrastructure. We already have early deployments of this model in production, and we expect to see much broader adoption as customers scale their private 5G deployments in their own environment.